Hello, we are from Group 1, Tutorial 8, and we are going to present to you the Problem-Based Learning 1 Mathematics for Semester 2, Session 2020 and 2021.
So for our PBL Mathematics problem, I would like to introduce our group member, which is 1, Aisyah Syairah binti Suhardi, 2, me, Alif Rashad bin Muhammad Yusof, 3, Andis Claudia Doni, 4, Muhammad Nuhazrin bin Hazli, 5, Nur Aina Akila binti Arli Hamdi.
I will start with the introduction for this problem-based learning. Descriptive statistics are used to provide simple summaries about the sample and measures. With descriptive statistics, it is simply describing what the data have been shown. In most research studies, we may have a lot of measures or a large number of people on measures. So, these statistics help to simplify large amounts of data in simplest way. Each descriptive statistics will reduce lots of data into a simpler summary. There are three major characteristics of a single variable, which are the distribution, the central tendency, and the dispersion. The distribution is a summary of frequency individual values or ranges of values for a variable. Most common way to describe is using frequency distribution. Next, central tendency is an estimate of the center of a distribution values. The three major types of central tendency are mean, mode, and median. Last but not least, dispersion refers to the spread of the values around central tendency. The two common measures are range and standard deviation.
Hello, my name is Aisyah Syairah binti Suhardi, matrix number FS20110083. I will start with the introduction for problem 1. For this introduction slide, it stated that discrete data is described as information that can be classified into a class of categories. Counts are used to represent discrete data. From the instruction given, the data was chosen from the official portal of Department of Statistics Malaysia under the option Labour Force Survey Time Series Statistic by State from the year of 1982 until 2018. Hence, the dependent variables chosen is the labour force by ethnic group, and the independent variables is the year from 2000 until 2015, means that the n is equals to 16. The randomly selected states are Johor, Kedah, and Kelantan. Number of Indian labours was chosen as dependent variable because it can simply treat as a discrete data as the instructions require.
Okay, so for problem 1, a data was chosen from labour force by ethnic group of Johor, Kedah, and Kelantan from 2000 until 2015 within the ethnic of India. Okay, so as you can see, the data of labour force by ethnic group of Johor from 2000 until 2015 within the ethnic of India is shown in the slide, and then the frequency distribution table has been created based on the above data. The first step to construct the data is to evaluate the class number K by the law of search, where the total number of observation in the data set is n equal to 60. Okay, and then you can see the data of the labour force by ethnic group from Kedah from 2000 until 2015 within the ethnic of India, and then the same method was used to find the frequency distribution to create the frequency distribution. And then as the third part, you can see the data of labour force by ethnic group of Kelantan from 2000 until 2015 within the ethnic of India, and also the same method was used for Kelantan.
Now let's move on with the first state, which is Johor. After we found the value of class interval K, which was stated by Alif, we are now going to find the value of range, in which was calculated by subtracting the biggest value with the smallest value. Hence, as shown in this slide, the value of range is 27. Thirdly, the class width was calculated by dividing the range obtained earlier with the number of classes, which is the class interval K. Hence, as shown in this slide, the class width is 5.4, which I rounded of 2, 6. All the calculated and obtained values are then used to fill in a frequency distribution table as shown in this slide. Thus, Table 1.1, the frequency distribution table, was based on retrieved data from Table 1, is the answer to question 2b. The frequency distribution table consists of class interval, frequency, cumulative frequency, lower and upper limit, lower and upper boundary, class width, and lastly, class mark. For the next slide, I will discuss problem 1, question 2c. So, in this slide, graph 1 shows the histogram obtained from the retrieved data of employed person by ethnic group in Johor within 2000 until 2015 year range. The y-axis is the frequency, which is the year, and the x-axis is the class interval, which is the total employed person. Next, in this slide, graph 1.1 shows the OGIF obtained from the retrieved data of employed persons by ethnic group in Johor within 2000 until 2015 year range. The y-axis is the cumulative frequency, which is the year, and the x-axis is the upper boundaries, which is the total employed person. Next slide for question 2c, graph 1.2 shows the frequency polygon obtained from the retrieved data of employed persons by ethnic group in Johor within 2000 until 2015 year range. The y-axis is the frequency, which is the year, and the x-axis is the class mark, which is the total employed person. Now, moving on with the next stat, Kedah, we are going to do the same thing by searching for the range, which is 16.7, and the class width, which is 3.34, in which I rounded off to 4. And then for the next slide, we're going to fill in the frequency table as we used to do from the former frequency distribution table. Next, in this slide, it shows histogram graph obtained from the retrieved data of employed person by ethnic group in Kedah within 2000 until 2015 year range. The y-axis is the frequency, which is the year, and the x-axis is the class interval, which is the total employed person. In this slide, graph 2.1 shows the OGIF obtained from the retrieved data of employed persons by ethnic group in Kedah within 2000 until 2005 year range. The y-axis is the cumulative frequency, which is the year, and the x-axis is the upper boundary, which is the total employed person. Next slide, graph 2.2 shows the frequency polygon obtained from the retrieved data of employed persons by ethnic group in Kedah within 2000 until 2015 year range. The y-axis is the frequency, which is the year, and the x-axis indicates the class mark, which is the total employed person. Now, as for the last state, which is Kelantan, the obtained range is 1.8, and the obtained class width is 0.4. The next slide here shows the frequency distribution table based on the data that we retrieved from table 3. In this slide, it shows the histogram graph obtained from the retrieved data of employed persons by ethnic group in Kelantan within 2000 until 2015 year range. The y-axis is the frequency, which is the year, and x-axis is the class interval, which is the total employed person. In the next slide, graph 3.1 shows the OGIF obtained from retrieved data of employed persons by ethnic group in Kedah in Kelantan within 2000 until 2015 year range. The y-axis is the cumulative frequency, which is the year, and the x-axis is the upper boundary, which is the total employed person. Lastly, this is the last slide for question 2c. Graph 3.2 shows the frequency polygon obtained from the retrieved data of employed persons by ethnic group in Kelantan within 2000 until 2015 year range. The y-axis is the frequency, which is the year, and the x-axis is the class mark, which is the total employed person. That's all from me.
A very good morning. My name is Claudia. I will be presenting for problem 1, question number 2, D, E, and F. For D, the calculation of summary measures, we obtain 3 tables for Johor, Kedah, and Kelantan. The table containing F, X, Fx, X squared, and Fx squared. From the table, we also obtain the mean and the standard deviation, also the interquartile of Johor, Kedah, and Kelantan. For the mean of Johor, we got 89.05 using the formula total of Fx divided by total of F. For the standard deviation of Johor, we obtain 1.81 using the formula given. For the interquartile, the first step is we find the first quartile, which is 85.8, the second quartile, 88.8, and the third quartile is 97.8. Hence, the formula for interquartile is quartile 3 minus quartile 1. So, the answer for interquartile of Johor is 12.0. For Kedah, we obtain the mean is equal to 54.5625 and the standard deviation is 1.598. From the table 2, we obtain the interquartile, which is the first one is 55, the second one is 56.46, and the third one is 67. Using the formula of interquartile, quartile 3 minus quartile 1, we got the answer for quartile of Kedah is 8. For Kelantan, the mean is 1.469 and the standard deviation is 0.427. Using the formula quartile 3 minus quartile 1, the answer we got is 0.2. Moving on to the next question, which is E, box and whisker plots for total labor force by ethics group in Johor and Kedah. Since the question only asks for 2 groups, so we opted for Johor and Kedah. Constructing box and whisker plots, outlier should be determined first by using 1.5 in a quartile rule, which is 1.5 times IQR. For this question, we also find the upper inner fins and the lower inner fins. So for this data, the biggest and the smallest values are 97.8 and 85.8 respectively, which clearly still in the range of the lower inner fins 67.8 and upper inner fins 115.8. Hence, from the calculation, diagram of box and whisker plots for number of labor force by ethnic in Johor and Kedah obtained. For the next question, which is F, symmetry and squeeness, the first thing we do is we find the percent coefficient of squeeness for Johor, Kedah, and Kelantan. For Johor, regarding to the graph 1, the histogram shows an increase in the frequency 1 to 6 and then decrease drastically with the frequency 4. The distribution was positively skewed, and since the mean has a larger value than the median, the percent coefficient of squeeness gives a positive value too. So it can be concluded that this distribution was positively skewed. For Kedah, from graph 2, which is in the question C, the histogram shows the number of labors drastically decreased from the frequency 8 to 1. The distribution was negatively skewed since the mean has a smaller value than the median. Also, by referring to the histogram, it generally has not a right long tail. The percent coefficient of squeeness also negative value, so it can be concluded that the distribution of Kedah is negatively skewed. For Kelantan, from the graph 3, the histogram shows the number of labors increases with the frequency 1 to 3 and to 8 and decreases with a frequency 2. The distribution was negatively skewed since the mean has a smaller value than the median. Also, by referring to the histogram, it generally has a long tail and the percent coefficient of squeeness also give a negative value. So it can be concluded that this distribution was negatively skewed. Hence, skewness measurements are used to characterize the form of frequency distributive curve. So the set of observation on labor force in ethnic in Johor, Kedah, and Malacca was not symmetrical as the mean, median, and mode are not equal. That's all from me. Thank you.
I will be explaining for the problem 2. Problem 2 question showed that you are employed as a statistician for a company that makes household products. So this shown the salesperson A, B, C, and D with the sale records for the past 6 weeks for these 4 salesperson. We are advised to search the mean for each salesperson by comparing the sales volume using the mean, and then choose an appropriate statistical measure to compare the consistency of sales. Here, we choose the coefficient of variation to find the consistency of sales for each salesperson. Solution 1. In comparing the sales volume for each salesperson, the mean must be found to get the sales volumes. This formula will be used. Total X will represent the total sale record in past 6 weeks by each salesperson. Meanwhile, N represents the total of weeks, which is 6 weeks. Hence, the sales volume for each salesperson can be directly calculated using equation above. So here we can see salesperson A for the sales volume is approaching 1,831 ringgit. Salesperson B is approaching 1,948 ringgit, while the salesperson C is approaching 1,310 ringgit, and the sales volume for salesperson D is around 1,604 ringgit. Therefore, to compare all the sales volumes from each salesperson was shown as below in increasing order of sales volume. You can see that is the sales volume that have been shown. C is the lowest sales volume, and you can see that the highest sales volume is from the salesperson B. For solution 2 is to compare the consistency of each sales. Here, coefficient of variation was chosen as an appropriate statistical measure. To calculate the coefficient of variation, the standard deviation for each sales will be calculated first using equation below. After the value of standard deviation was obtained, the coefficient of variation was calculated as the equation below, where coefficient of variation is equal to standard deviation over mean times 100%. So you can see here for the salesperson A, the consistency of sales for salesperson A is 4.16%. For salesperson B is 16.80%. Consistency of sales for salesperson C is 11.41%, and salesperson D is 9.67%. Therefore, the comparison of the consistency shows that salesperson A has the highest consistency on his sales because it has the lowest coefficient of variation. The consistency of sales are shown below in increasing order. Meanwhile, we can see that B is the lowest consistency because it has the highest coefficient of variation, and we can see that the highest consistency is from the salesperson A.
Problem 3. The question is, assume you work for OSHA, Occupational Safety and Health Administration, and have complained about noise level from some of the workers at the state power plant. You're charged the power plant with talking decibel reading at 6 different areas of the plant at the different time of the day and week. The result of the data collection are listed. Use box plots to initially explore. With the protective earwear, the safe hearing level is approximately 120 decibels. From the statement, all data are collected in terms of tables, like the diagram below, so we have 6 areas. So for area 1, first of all, we must find the mean from the data given. So we can find the mean by using the formula x bar equal to sum of x over n, given that sum of x is equal to sum of all the data, while the n is the number of all data, which is n equal to 15. So we got there that x bar equal, which is mean, equal to 52. Next, we must find the median. To find the median of the data, all the data must be arranged with increasing order, which is from 12, the smallest, to 100, the biggest. The data has an n, which is the number of the data, equal to 15, which is odd number. So the formula can be used as n plus 1 over 2. So median is equal to 15 plus 1 over 2, which is we got the observation median is the 8th observation median equal to 56. Next, to find the quartile, first and the third quartile can be determined by referring to the median, which is the 4th observation and 12th observation respectively. So therefore, the first quartile is equal to 32 and the third quartile equal to 65. The interquartile range can be found by third quartile minus the first quartile, which is 65 minus 32. So we got the interquartile range equal to 33. As for the skewness, by comparing the median is clearly larger than the mean. So if the mean is smaller than the median, the data was negatively skewed. And lastly, we must find the box and whiskers plot. Outlier should be determined first by using 1.5 interquartile rule. So 1.5 times with interquartile, which is 33, we got it as 49.5. Then, the upper and the lower inner fence for data was determined by using the quartile plus 1.5 interquartile range and first quartile minus 1.5 interquartile range for upper and lower inner fence respectively. So, as the upper inner fence is third quartile plus 1.5 interquartile, which is 49.5, we got the upper inner fence equal to 140.5. As for the lower inner fence, which is the formula is the first quartile minus 1.5 interquartile range, which is 1.5 interquartile range is equal to 49.5, we got the lower inner fence as negative 17.5. For this data, the biggest and the smallest value are 112 respectively, which is clearly still in the range of the lower inner fence, which is negative 17.5, and upper inner fence 114.5. So there is no outlier for this data. So the box and the whiskers plot given in the diagram. As shown in the box and whiskers plot, the highest observation is 100 decibel and does not exceed 120 decibel. Protective earwax is not required in this area as it is safe hearing level. As for the other area, the way to solve the problem is still the same, which is we need 4 main components, which is mean, median, quartile, and skewness. So for area 2, the mean is 60.53 and the median is 59. The first quartile is 52 and the third quartile is 78. So we got the interquartile range 26, while the skewness is positively skewed. For area 3, the mean is 74.27, for median is 66, the first quartile is 59 and the third quartile is 83, the interquartile range is 30, and last but not least, the skewness is positively skewed. For area 4, the mean is 29.93, the median is 25, the first quartile is 20, the third quartile is 34, the interquartile range then we got 14, so it is positively skewed. For area 5, the mean is 98.73 and for median is 99. The first quartile is 68 and the third quartile is 120. So the interquartile range is 52 and we got the skewness as symmetrical distribute. And for area 6, the mean is 70.13 and the median is 67. The first quartile is 49 and the third quartile is 93. So we got the interquartile range as 44. So it is positively skewed. So this is the overall view and picture for box and whiskers plot for all area according to the color based on the chart. Just two regions, Area 5 and Area 6, has sound intensity level greater than 120 decibel as seen in the box plot above. As a result, staff in this region should wear hearing protection as the hearing threshold was 120 decibel, which is the safe intensity level. Workers in other areas does not need to wear hearing protection since the noise level is less than 120 decibel. So we can sum up all the data and the finding we got. The safe noise area is Area 1, Area 2, Area 3, and Area 4, while the unsafe noise level area is Area 5 and Area 6.
Now for the conclusion. Conclusively, the descriptive data had been used as a whole in solving problems from this research. In problem 1, the frequency distribution table had been used for each states in Kedah, Johor, and Kelantan. The graph of histograms, ogives, and frequency polygons also have been managed to construct. Calculation of mean, standard deviation, and interquartile range also able to be shown. Side-by-side box and whisker plots also used in describing the symmetry and skewness of the data. For problem 2, mean was used to compare the total sales of each salesperson, and the coefficient of variation was used to determine the consistency of the sales. In problem 3, box plots were used to find the level of noise by calculating the area of the box. To sum up, students are able to use different types of techniques and calculations in order to present and solve the data given. Here are some references that we have been used in completing this problem-based learning. And many thanks to all. Stay safe and keep healthy everyone. That's all from us, Group 1 Pbl Maths, Tutorial 8.